Okay, back to learning C. We are on character input and output. We are now going to consider a family of related programs for processing character data. You will find that many programs are just expanded versions of prototypes that we discuss here. The model of output, input, and output supported by the standard library is very simple. Text output or input or output, regardless of where it originates or where it goes to, is dealt with as streams of characters. A text stream is a sequence of characters divided into lines. Each line consists of a 0 or more characters followed by a new line character. It is the responsibility of the library to make each input or output stream conform to this model. The C program using the library need not to worry about how lines are represented outside the program. The standard library provides several functions for reading and writing, one character at a time, of which getChar and putChar are the simplest. Each time it is called, getChar reads the next input character from a text stream and returns its value, that is after C equals getChar. The variable C contains the next character of input. The characters normally come from the keyboard input from files as discussed in Chapter 7. The function putChar prints a character each time it is called. There's putChar parentheses C. Prints the contents of the integer variable C as a character. Okay. C contains the next character. Okay, so I think getChar puts it inside the variable C, and then putChar prints the contents of the integer. Usually on the screen, calls to putChar and printf may be interleaved. The output will appear in the order in which the calls are made. Okay. Given getChar and putChar, you can write a surprising amount of useful code without knowing anything more than about input and output. The simplest example is a program that copies its input to its output one character at a time. Read a character. Well, character is not end of file indicator. Output the character just read a character. Converting this to C gives include. Okay, now we're back up here. We're going to go int C, so we're declaring a variable, and then C is going to equal getChar while C does not equal EOF. What the fuck is that? putChar C equals getChar. Let's see what this does. And I'm in file. Input and output. Yeah?
You take your stuff out of the drive?
No.
Why not?
Because I'm busy. Just give me a couple minutes. It's only on the internet forever. Get car, Control S, GCC, and then we're gonna go -O, output.c. Output. Integer from pointer without a cause. What did I fuck up? Assignment to int from int oh you're a integer without a cause. Rebel without a clue. Integer without a cause. And that gave us input output. Can I run this in the console? That's not functional. that did something. You know what? Let's open up this one. Let's try. Okay, that worked. Which means the reason this isn't working is because I'm using it incorrectly. The relational operator. Okay. I gotta go get that shit done. Fuck me. I had too much caffeine again. God damn it. It's always super hard to get the right amount. Okay, where was I? The relational operator not equal means not equal. Copy input to output. So if I run execute run console. Here's what I want to do. Fucker. Okay, that's what it does. I was using it incorrectly. Haha! It's called itself a dum-dum. Okay. Just copies. What appears to be a character on the keyboard and screen is like everything else stored internally, just as a bit pattern. The type char is specifically meant for storing character data, but any integer type can be used. So I can type this 6 side. Whoa, that, okay. And it only prints 69420. We do. Huh. Okay, so it copies pretty much everything. The problem is distinguishing the end of the input from the valid data. The solution is that the getChar returns a distinctive value when there is no more input, a value that cannot be confused with any real character. This value is called EOF, for end of file. We must declare C to be a type big enough to hold EOF in addition to any possible char. Therefore, we must use int. Doesn't matter as long as it is not the same as any char value. By using the symbolic constant, we are assured that nothing in the program depends on specific numeric value. The program for copying would be written more concisely by experienced C programmers. In C, any assignment such as C equals getChar is an expression and has a value, which is the value of the left-hand side after the assignment. This means that an assignment can appear as part of a larger expression. If the assignment of a character to C is to put inside the test part of a while loop, the copy program can be written this way. And now it has a new version. Which moves this. I might have to read that whole thing again because I have no idea what it just said. I'm going to get rid of this. Put char is going to say the same. And then we're going to put or rewrite this whole thing from the ground up. While C equals getChar is not equal EOF. Wait. Problem is distinguishing the end of the input from the valid data. The solution is that getChar returns a distinctive value and there is no more, called EOF, or end of file. Let me look up what EOF is. Indicates the end of an okay. So while C equals getChar, while C equals getChar does not equal end of file, put char C. Okay. Interesting. Did I do the right one? Okay, I did. I don't know. So, get car, or while C equals get car, which is going to be this. So right now C, ooh. C is right now equal to there will be blood, but does not equal end of file. Can I hit tab? Oh, I can. Then it puts the characters. I don't understand put car. I feel like I understand get car, but what is put car? The put car method in C is used to write a character of unsigned car type to std out. This character is passed as a parameter to this method. Syntax int put car int car. Parameters: this method accepts a mandatory parameter car, which is the character to be written to std out. This function returns a character written on the std out as an unsigned car. It also returns EOF when some no, that still doesn't make sense.
Hello and welcome to Linux Int YouTube channel. In this video we are going to discuss the put character function in the C programming language. So the function put character is used to print out a single character to the standard output stream, and it requires the library stdio.h. So you can see the syntax of put character on your screens right now. As you can see, the return value of this function is of integer data type. For the arguments, it takes the character that you want to print to the output stream. So now coming to code, first we need to include the required header file, which is stdio.h. And then for this example, I'm also going to include the string.h library. Then create our main function. And then in here, I'm going to create a character array and I'm going to call it string. And then I'm going to give it some string value. Let's say hello world. And then I'm going to use a for loop to iterate through this array. So I'm going to start with integer I starts at 0. Integer I goes until it reaches string length function of the variable str. And then I want to increase my operator by 1. And then to print out every character to the output stream, which in case would be our terminal, I'm going to use the function put character, and inside here I'm going to pass in str, which is my variable, and the index would be I. So basically I'm iterating through every character in that particular array. And then to make sure that we're actually printing out individual characters to our terminal, I'm going to use a printf function, and I am going to simply print out a new line for every iteration. So now if I run my code, you can see that it printed out our whole array, but every character was printed on an individual line. So that is how you use the function put character to place a character to the output stream.
Please press the subscribe button, tap on the bell icon and never miss an update from.
जैसे कि मैंने बताया printf और scanf.
My word, that sounds terrible. To the standard output. Hey, is this guy doing the same thing as I am? He is! Cool! Oh. Hmm. What if we change this to if? That is not supposed to be capitalized. That is like, what the frick is going on here? Okay. I'm trying to break it on purpose. Because according to all this, put car only prints a single thing at a time. So if I go oh, okay. Only prints a single character. I get it. Big brain. Okay. So this has to be while, because it has to do it over and over and over and over and over again. If it's not doing it over and over and over again, then it can only print a single character. There's also some stuff saying that it's a lot faster than the other one because it doesn't have a whole bunch of stuff built into it for formatting and extra characters. So this is much faster code, which is good because I like fast code. I ordered a Bible. Where is that Bible? Oh, I wish it would not do that. Fine! Bastard. Transit orders. Oh, it's arriving Thursday. That's good. This is special because this is the first Bible I've purchased. Okay, but we know what put car does. And I feel like I understand how it works. And then test was a end of file signal if not the body of while is executed, printing the character. The while then repeats. When the end of the input is finally reached, the while terminates. So does main. This version centralizes the input. There is now only one reference to get car and shrinks the program. The result program is more compact and once the idiom is mastered, easier to read. You'll see this style often. It's possible to get carried away with and create impenetrable code, however a tendency that we will try to curb. Parentheses around the assignment within the condition are necessary. The precedence of not equals is higher than that of equals, which means that in absence of parentheses, the relational test does not equal will be done before the assignment equals. Oh, that's interesting. Okay. The precedence does not equal has more precedence. Oh, let's try it without it. We're going to find out what happens when we break the shit out of this. Because remember, learning decoding is just breaking your code. It does nothing! Interesting. Recompile so that we know it works. This has the undesired effect of setting C to 0 or 1 depending on whether or not the call of getCar encountered end of file. More on this in chapter 2. Exercise 1-6. Verify the expression getCar does not equal EOF is 0 or 1. So if I remove this, I remove this. This right here is equal, according to this book, to this. And what it wants me to do is, because apparently what it will do is it will set this to either 0 or 1, and it's not telling me which, on purpose, probably, because it wants me to fuck around with the code, break it, see what's up. This is what we're going to do. I don't need to do that, I need to do this. Good habits. It's not telling me, bro. I guess we could try. And then you do, what is it, like percent D, I think? Might be percent C. I don't know, I guess we'll just have to find out. And then C. That should be a functional statement, I'm pretty sure, right? It is. Whoa. I think it's equal to 1. That's a lot of ones. How many? Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oh yeah, it's worth 1. Okay. Oh wait, no, it might be the D. No, D was for. Shit. What is this? I know it's not modifiers, but you know. No, because the other one is an escape sequence. This is not an escape sequence. This is a data thing. Shit, what's the name of those things? It's a format specifier. What are format specifiers? It's a signed integer. Let's try C. Okay, I'm going to say it's C because, or not C, it's going to be 1 because it said the other thing was 1. That's going to be a check. And a small mark under the 1 so that I know what it is. Write a program to print the value of EOFE, or EOF. That's pretty easy. Actually, I regret that. Let's put that back. Let's just add on to the back. Actually, let's not even stick it in there because we don't have to. Let's print it before everything else happens. Can I just do that? Is that possible? Or do I have to format it? I don't know. Nope, I have to format it. We're gonna do. -1. Huh. That's cool, I guess. Next program counts characters. It is similar to the copy program. I think I should probably take a break. I will be back. Actually, no, let's do this, then take a break. I am going to create a new file, though. I'm going to call it input output. This will make it easy to edit GCC statements. So if I go here, just go 2, 2, and then we're done. Main. Okay, the next program counts characters is similar to the copy program. This is going to have a long, ooh, fancy, long. While get card does not equal EOF. Increment and C. Printf %d dash new line. Oh, wait, %1d, so it wants it to print on the same line, or the same position. NC, and we're going to put that on the end. I don't think this is going to work. I am incorrect. Fuck. Run console. I don't think it's going to work because it doesn't have one of these to be specific. I think it needs these. I don't know if this will help. Certainly didn't hurt it. Oh. 8, 9, 10. Oh, that's kind of funky. Why did it skip 10 when I put in 9? Oh. Oh, this is very funky. What the shit? Oh. Hmm.